Hello, I'm Bowie from School of Design and Environment with the Diploma in Design. This is a short introduction into how designers can bring quick ideas from sketches into 3D modeling. You will see how designers can bring doodles and ideas to life into a digital platform where the ideas can be visualized with all the details that you can imagine all on a screen. In a typical design process, there are many phases, but here we are taking a quick look at one of these phases where designers are sketching and exploring ideas, both with paper and pen, also on digital platforms. So when we find potential ideas, we identify them, and then they can be brought into the digital platform to be developed in detail for evaluation, for just to try. This is done with computer-aided design, or CAD, CAD in short. Let's see how this is done. In this case here, this is a concept model for a power tool, a battery-powered chainsaw. We are taking the sketch, the digital sketch that you saw earlier, directly bring it into the 3D software. And this is called a picture frame feature. And then we lock that drawing in a layer so that we do not accidentally move it. And what we do is we can actually draw curves using the drawing, the sketch, as a reference. And we can create the curves that will define the profile, the side profile, and well, overall the form of the design, the idea that we had. Using only the 2D sketch, either digital or manual sketch, and we can actually use this to start creating a 3D model. So what we are doing here is using simple curves, and then we create fillets, basically radiuses, that join these two curves to make it into a more complex curve, which will become the rail in another feature that we use to create the surfaces. So you see now the two simple curves has become a much more complex curve. And at the end of this curve, we want to create a cross-section curve. We create it using another simple curve. We just draw, as you can see. And then what we are going to do is we're going to mirror that across the central plane because we want it to be symmetrical on both sides. And as you can see here, and then what we can do is join these two curves into one single curve, the cross section. And then we also join the three curves into one single curve, forming the rail. And then we use this feature called sweep one rail. The long curve is the rail and the short curve is the cross section. And see, very quickly we've got a complex surface. This will form one of the surfaces that would define the profile, the side profile of from the sketch. And now you see how we can progress to draw all the curves using the sketch as a reference. And so we work between the 3D image and 2D image in our perspective window so that it's easier to see what we are doing most of the time. So we toggle between 2D and 3D as we are constructing the surfaces. And you can see how fast it could be once you have the curves, and then we create the individual surfaces, and later you see how we trim them and join the surfaces to become the main body. For this curve, at the end, we're using another simpler, well, it's also a simple way of constructing surfaces, because we are imagining that the main body will be thicker, and where the handle is, where you see an opening at the back, will be thinner, so that the user is able to hold it more easily. And from the top view, you will see that there is a curve there, and we've created the surface, and we again mirror it because we want it to be symmetrical. And we are continuing to create the other curves and the other surfaces to trim them. This is a much simpler surface. We're going to use extrude curve, surface extrude curve. And basically, extrude a surface out, a straight surface out from the two curves. That will define the two ends of this whole product, the main body. This looks very complex now because now it's actually 6 surfaces defining all the 6 sides of the object. But as we look at it, you'll find that it's not that difficult to actually visualize it. And then now we're trimming the parts that we don't want anymore, the surfaces. We're using a feature called split, using one surface to split the other one. So one of the surface will be used as a knife to cut the other surface. And here we can trim off the rest of it again. And you start to see the main body coming out. And then what we want to do is we join all these 4 surfaces together to form a full object, 4 main surfaces, so that we can use these 4 surfaces to cut the 2 at the end, at both ends. And now as we take away what is not required anymore, you see all the 6 surfaces, if we join them, it becomes a full solid. In Rhino, when we join all the surfaces together, it is considered a solid. And we're going to continue to cut an opening for the handle using the curves that we defined earlier as well. using the sketch as a reference. And we're going to extrude the surface here and use that to cut it. Basically, we're going to cut a hole on the two side surfaces. But first, we're also going to create curves so that we can use the curves as references to build the rest of the internal surfaces, which you will see later. So here we've managed to get the curves from intersection surfaces. Because these are complex surfaces, and then the curves are not simple 2D curves, they're actually 3D curves. So what we've got is now the marked out curves on the surface itself. And you can see also that as we start to create surfaces and curves, we are most of the time toggling between wireframe mode and shaded mode. So that it's easier to see and to work with. And now we have actually cut the two surfaces on both sides. And now you see that there's a hollow. So what we're going to do next is we're going to use those curves as a reference and create the internal surfaces of the handle. So this feature here we are using is called sweep two rail. So two main long rails and two cross sections. And we are able to create a surface like that. And so we're going to continue, but for the next set of curves, we're going to use another feature, which is curve network, because with this feature, we can actually define tangency and tangent to surfaces and all that. As you can see here, now I'm making it tangent to the surface that we've already created so that we can get a smooth surface throughout from left to right, forming the internal part of the handle surface. Then we join these two surfaces together. And from this view, from the front view, we can actually, if we did not make any mistake with it, we can actually mirror it and we'll have the other side of the surfaces for the handle. And we join this all together and you'll be a full closed surface. The basic surface for a product body. And here we are going to carry on to build more radiuses, because in a product like that, normally a sharp edge like that with the surfaces wouldn't work very well. It would not be very ergonomic and won't be very nice to hold at all. So we are building using the edges, defining the edges and build radiuses around that. So it creates a smoother curved surface there. And then we can continue to start to build radiuses on the outside edge as well, so that it becomes a softer form. So we decided that it could be too big, the radius, so we're going to make it a little bit smaller. Sometimes it's an evaluative process where we actually check, look at it, and then we modify it from here. And for the bottom curve, we're trying to select a bigger radius there, 15 mm radius. And then we're going to do an overall radius on the two edges as well. And it helps to see, to go back to 4 views to see overall from every angle what it will look like. And then we bring it back, turn it back on the layer for the sketch to see whether if it's still following the sketch with the form and the shape. And this is how you see very quickly that 2D sketch has become a 3D. It has become a 3D surface. We turn on all the curves to have a look. And what we want to do is take one of the curves at the back and cut off that sharp part and then use it for another individual separate part. So we extrude a surface, a flat surface there, and cut off that part. So we're selecting the body and then the surface to cut the body. Then we can switch off that part and you will see this. When we join this back to the main body, you have one complete surface as well again. And you can see that the side profile is very close to the sketch. So the design intent is actually still relevant. And from here, you can actually evaluate further. And due to the time constraints, we're going to show you how, let you see how the whole main assembly is created and visualized. We're going to turn on the different layers and you will see all the separate parts. Now we've just turned on the back hook and the battery, main body, the top part of the battery. And all these parts are individually created with curves and surfaces to form the whole main body and the whole product. You see the purple part, which is the power switch, and the red part is the safety switch. And that is the motor end cap. It will combine with the top handle of the product. And the bluish shape, it is the front support. And that is the branding for the product. So this is the front guard, which is a protection for the user, and the main body now we turn on, which we created in the first place. And this is where the main motor is, and it's connected to the handle. The next one should be the handle, which is coming up. And then you start to see how this whole product can come to life from just one sketch. Because as we draw in 3D, we actually can visualize more and more clearly what the product could look like. And you could work out all the different details. And this could be drawn in actual 1-to-1 full size. So everything, the proportion could be correct. And you could use this data and actually create a 3D print to create the whole 3D object so you can hold it. And that is one of the applications of doing or working in 3D modeling. And we've just turned on the blade, the chain, and we shaded it. Now go to shade mode so that you can start to see all the details and the features. And that's the chain guard. And here you will see the whole product, but this is a right view. So we go to the 4 windows and we look at it in perspective so that we can spin it around. And now we see the whole view and all the details that has gone into it. Every single part. And there is another detail at the top. And this is a good way to evaluate the surface and the detailing, because we can spin around, we can go to shaded mode, and you can actually fully see the details. For the little small details, you can actually zoom in and see. We can even switch off the layer so you can see where the battery sits, where the recess is, and what it could be. And this will be the logo that is on the product. We visualize that the pinkish peach color part could be a metal part covered by the gray rubber, which actually will protect the motor inside. And you see this could be a metal guard in front with a rubber on the facing the user so that you will protect his hands. And this could be the exhaust, the ventilation for the motor. And that will be the rear hook, where you could maybe hook it to a chain or something, and then where you can actually hang it. One of the advantages of working in 3D modeling, because you can actually see it like in real life without having to spend a lot of time, but you can visualize and you can communicate your design intent, your idea very effectively. by showing this, most people would understand the idea that you're trying to bring across. And then here we're going to probably look at, there are features in this software that helps us evaluate the surfaces in analyze. We can analyze surface using environment map, and then we select that, and then we select the background, and you can see if the surface you created is smooth and regular. This is a pretty easy way to actually assess and analyze the surface if there are any problems with the surface. Is it symmetrical and all that? And we can use different backgrounds to project onto that surface so that we can actually see any faults if there are. And because this was created separately, we can actually also select the surfaces for the graphics to be included in the analysis. So you can actually see what it would look like with this extrusion of the graphics on this main surface and add it to the analysis. As you can see, every single part was built individually. So although it is easy, but it still requires a bit of patience and attention to detail. Now you can see how the reflection will look like if this was a metal part. And so we go back to the 4 windows so that you can see the product in all 4 different views. What do they look like and the proportions. Another thing that we can do when we create in 3D is from the 3D, we can actually create 2D drawings, which are very conventional way of communicating ideas and design intent. And we can create conventional orthographic projection drawings, which can be used for manuals, for drawings to show the size, the view, the profile of the products. And this is how we bring something from 2D, a sketch, into a 3D. So We hope that this short introduction has given you some insight into how 3D modeling is and how do we bring 2D sketches into a 3D model. Thank you.